Okay, explaining this one using the hills and holes analogy, which you definitely don't have to use and you definitely shouldn't use if you're writing explanations on like an AP test or something. The reaction was given, these colors were given. From the colors, I know that the right side is purple. Anytime I get a right shift, it will be purple. The left side is yellow and clear, which together means anytime I shift yellow, anytime I shift left, I would see yellow. So my options for answer choices for the color changes will be yellow or purple. When Cl minus is added, we have more reactants, more stuff over here, like a hill on the left. That would shift right to flatten out. The right side is purple. Same idea, if this is added, a hill on the left, shift to the right to balance out, we would see purple. Heat being added. Well, before I can determine what heat does, I need to look at the heat of reaction that's given. Because it's positive, it's endothermic, heat is entering the reaction, so heat belongs over here. If this were negative, it'd be exothermic, I'd write heat over here. But since heat is on this side, now when I consider adding more, again, it's like a hill on this side where the heat is, shifting right to balance it out, and I see purple. NH3 removed. Well, now we're talking about the NH3, which is over here. When I remove it, I don't have enough of it. I have a hole on the right-hand side. I want to fill that hole in, so I'm going to take stuff from the left, shift it to the right. When I shift to the right, I see purple. E is asking the same thing, and when we skip over to H, it's just asking you to explain what happened in number 1E. So, H plus is added. Well, H plus not in my reaction. So when it's added, it's going to steal something. And it's your job to figure out what it steals. Now, based on the fact that when we add H, we make NH4, I would say it's safe to assume the H is stealing the NH3. Stealing the NH3 is no different than removing it. So for the same reason as D, if it shifts right, I see purple. An appropriate explanation for H would be the H plus bonds to or seals NH3, removing it. If you want to say so there's a hole on the right, you can't, and it shifts right. The right side is purple. Same idea in F and G. We're adding something that's not a part of the reaction, so it's going to steal, but it's up to you to figure out what it steals. Based on the color change that we see, we can determine what side it's stealing from. Remember, when we add something that's not in the reaction and it steals, whatever it steals will have a hole, will be missing. So if we see yellow, we must have shifted left, which means there was probably a hole on the left from whatever Pb plus 2 stole. So I know Pb plus 2 is going to steal something from the left. That's the only way I'd see yellow. Now it's just a matter of the fact that it's a positive, so it's probably going to bond to and therefore steal the negative. So it steals the chlorine, and then we shift left. Steals the chlorine, removing it, or steals the chlorine, creating a hole on the left. When we add something we see purple, because we're dealing with something stolen, it must be a hole on the right for us to shift right and see purple. A negative is going to choose to bond with the positive, so it would bond to or steal CO NH3 5Cl plus 2.